Class, were you amazed by the uses of mirrors in the optical devices that we have mentioned? This time, let us be more amazed with the uses of lenses in optical devices. But bear in mind that as we move along with the lesson, you should be able to identify ways in which the properties of lenses determine their uses in optical instruments. We have previously defined that a lens is a piece of transparent material that is shaped so as to cause light rays to bend in a specific way as they pass through it, whether that means making the rays converge to a specific point or to diverge as it for a specific point. The material used could be a piece of glass or plastic, and the shape of the lens determines whether it causes light rays to converge or diverge. The word lens comes from the Latin word lentil due to the similarity in shape between a converging lens and a legume. This was the table given to you in Module 3. This table tells us the comparison between a convex lens and a concave lens. Try to recall it once again. A convex lens refers to the lens which merges the light rays at a particular point that travels through it. Its curves are outward and it converges light. The edges are thinner while the center is thicker. On the other hand, concave lens can be identified as the lens which disperses the light rays around that hits the lenses. As you can see, it is curved inward and it diverges light. The center is thinner as compared to its edges. Class, let us now familiarize ourselves with optical instruments that uses lenses. Are you familiar with this one? Or this one as well? These are just some of optical instruments that uses lenses. Are these optical devices familiar to you as well? This is a magnifying lens. A magnifying lens or glass is a convex lens. Convex means curve outward, like the underside of a spoon or the dome of a sports stadium. It is the opposite of concave or curved inward. A lens is something that allows light rays to pass through it and bends or refracts them as they do. Class, a camera uses a convex lens or a converging lens. And the system of lenses in a camera performs the same function as the lens of the eye. Another use of lenses is the eyeglass or contact lenses. And you should remember that if you are nearsighted, this means your eye lenses create images in front of the light-sensitive retina in your eyes. So you need diverging or concave lenses to move the image further back. On the other hand, if you are farsighted, this means that the lenses in your eyes would produce an image further back than your retinas. So you need converging lenses to correct this issue. You have used microscopes in school, particularly during your lessons in biology. Microscopes work by using biconvex lenses or lenses with two convex sides to produce a magnified version of the images. Microscopes are a little more complicated because they usually have multiple lenses, but they produce magnified images in basically the same way. As on microscopes, these have another lens in the eyepiece to make sure the captured light is in focus when it reaches your eye. Have you ever used a binocular or a telescope? especially in viewing distant places that you want to see clearly? If you put two convex lenses in a closed tube, presto, you have a telescope. You can make your own telescope easily enough with a couple of magnifying glasses and a cardboard tube wrapped around them. Binoculars are simply two telescopes side by side, one for each eye. But there's a catch. When light rays from a distant object pass through a convex lens, they cross over. That's why distant things sometimes look upside down if you look at them through a magnifying glass. The second lens doesn't sort out that problem. So binoculars have a pair of prisms or large wedges of glass inside them to rotate the image through 180 degrees. One prism rotates the image through 90 degrees, then the next prism rotates it through another 90 degrees. So the two prisms effectively turn it upside down. The prisms can either be arranged in a back-to-back arrangement or at 90 degrees, known as foro prisms. Check if you understood our lesson very well. So we have discussed about lenses and mirrors. What particularly does mirror do to light? How about lenses? What does it do to light? We have discussed everything about mirrors and lenses and their applications to different optical devices. In summary, let us go back and remember the difference between mirrors and lenses. Remember that a mirror is a glass with one side silvery backing produces an image by reflection on only one surface. On the other hand, a lens is a transparent substance that produces images by refraction in any surface of the two surfaces. There are two major types of mirrors. One is the flat mirror and the other one is the curved or the spherical mirror. A convex mirror diverges light, while a concave mirror converges light. On the other hand, for lenses, we also have concave and convex lenses. Concave lenses diverges light rays, while convex lenses converges refracted light rays. Optical devices that uses lenses, on the other hand, we have the magnifying glass, we have the camera, eyeglasses or contact lenses, the microscope, and we have binoculars and telescope. My challenge to you now, my dear students, is to make your own periscope. You may use indigenous materials, but of course take note, a periscope has a mirror in it. Thank you for viewing my lesson. I hope you learned a lot today. Bye!